guys, I'm back after so many days, actually months. I'll be uploading now videos on mechanical engineering as I have promised earlier, and thanks for subscribing. And today we are studying about discussing about what governor. It's a simple type of governor where this thing that you are seeing in the red thing, the red marks, the red round things are the fly balls. Okay, and this one, this thing is the spindle, which actually rotates with certain angular velocity, and this is the spindle where the suppose this is the arm A and this is the arm A dash. These two are pivoted in this thing, in this point O, suppose, and these two, this one and this one, are the fly balls. Okay, so since it's a symmetrical thing, a symmetrical mechanical equipment, so we can take a study either side of the thing. Means what I'm saying, either the left side or the right side. Suppose we are supposing this is the left side. Okay, this is the left side. Okay, since this is a mass, this is a fly ball, so it will have a weight. Sorry, it will have a weight. It will have a weight like that, mg, right? And since this rotates, this entire thing, the upper arms A and the lower link B dash and upper arm A dash with a certain angular velocity with the spindle, since this spindle is connected to engine, as you know, right? So what happens, this fly balls actually rotate with a certain centrifugal force Fc. So I can show it here, Fc. So your Fc is nothing but m omega square r, where omega is the angular velocity of the entire spindle and also of the balls, of the fly balls, and m is the mass. That's why we have taken mg, mass of the fly balls, and r is this distance. This distance, yeah. This distance is known as from the center of the ball to the center of the spindle, because this spindle has its own axis on which it is rotating, right? Okay, so Fc, your centrifugal force, is your m omega square r. Okay, and this one, this is your mg. So if you see, there will be a tension created here. So this is 3 force, as you can see. This small w, that is the weight of the fly ball, considering the left portion of the governor we are doing, and this is the centrifugal force. If you can see, if you can draw it, it is somewhat like that. Sorry. Okay, somewhat like that. Let me take a different color. Okay, and this one, yeah, here it is Fc, this one is T, and this one, what should I say, this is mg. So if you see, the Fc and the mg force makes 90 degrees with each other, right? And if we extend it, this is a certain angle. Okay, and if you see certain angle, suppose theta, so what will be this thing, this angle? As you know, 180 minus theta, because the entire angle is a straight line angle, right? And what would be this angle? The angle between Fc and T, the tension, it will be 90 plus theta. So you can see there are 3 angles and 3 forces. So you can use the Lami's theorem. Lami's theorem states this Fc by sine of the angle of the other two, between the other two forces, that is 180 minus theta. Okay, Next, mg, this thing will be sine 90 plus theta. Okay, and there will be another thing, that is t. T will be what? Sine 90. Alright, so I'm clear with this, because whenever I'm considering this using Lem's theorem, okay, using Lem's theorem, as you all know, Lem's theorem. Yeah. So FC, the opposite angle is 180 minus theta. Mg, the opposite angle is 90 plus theta. And that for the T, the tension in the arm A, suppose it is 90. Okay. So if we solve it, it will be like, if we put the equation here, m omega square r, as you know from this thing, m omega square r by sine theta. Okay, because sine 180 minus theta is sine theta, and this is mg, sine 90 plus theta is your cos theta, right? Okay, so m gone. So if we see, if we take it to the other side, the sine theta, what actually happens? Omega square r is equal to tan theta. All right. Okay. So your tan theta, what can I say about tan theta? Can you tell me? See, this is your r and this is your theta, isn't it? So what I was telling, this, if you see, this tan theta is nothing but, here I am writing at the top, as you can see, omega square is square. Okay, omega square r is equal to tan theta. Tan theta is nothing but, this is r, this distance is r, right? And if we see this distance, or pivot to the center of that thing, fly ball, this is our h, our governor height. So if we see, this tan theta is nothing, but your r by h. In place of tan theta we are putting r by h. So we can remove, what we can remove? R we can remove, isn't it? Let me see, there should be another thing too with the thing. There is a g with also here. Yep, with this g, you can look at the bottom right corner, g. Yeah. So your equation becomes quite like that, omega square by g is equal to h, isn't it? Sorry, it is 1 by h. Yeah. So your, if we put omega equal to 2 pi n by 60, we have the constant value 2 pi and 60 and the value of g as 9.81 meter per second square. So what will happen? H will become 895 by n square. So the equation that where h is the height of the governor is can be written as 895 by n square. How do we get this value? Is by putting the value of expression of 2 pi n by 60 and the value of g. Thank you. So we will be discussing the other types and we'll be comparing later on with the other type of governor like Powell governor and Porter governors will follow. Thanks for watching the video. We'll be back and discussing other governors. Thank you.